Hi, Gabe.
Hi.
All right, welcome to the test review for rational functions, polynomials and rational functions. Sorry, no YouTube live, technical difficulties and such. Yay. All right. So what we're going to do, get your hand out of there, doggo. All right. We will start with graphing of the most basic of parent functions of polynomials. What's really important when we're looking at these is the exponent. So what is the parent function that we're dealing with? And then we can talk about the transformation that happens from there. So since our exponent on this one is to the fourth power, our parent function is x to the fourth. Okay, that one's obnoxious. But what's really important is that it's even. These ones are all about being either even or odd. Like this one over here, this is x to the fifth, which is odd. Okay, so that's what's most important about these is knowing whether it's even or odd. When it's even, our 3 points that we need to make sure that we have to transform are 0, 0, 1, 1, and then negative 1, negative 1, positive 1. Those 3 points are our parent function, and then from there we're going to transform them. For when it's an odd exponent, our 3 points are going to be 0, 0, 1, 1, and then the only difference will be negative 1, negative 1. All right. From there, we can do our transformations. Inside the parentheses is x. Pen technical difficulties now. Inside the parentheses is x. So that's our left to right action. So that's what this guy's going to be. This is going to be left 2. Then the one on the outside, that's our up-down action. That is going to be not up. That's going to be down 1. Okay, in the parentheses is going to be opposite sides. So those guys are going to do the opposite of what we expect them to do. So we're going to take all of our points and we're going to go to the left 2. Left 2. And then we're going to go down 1. Down 1. So there's that first one. Left 2, down 1. Left 2, down 1. And that's all we need with these ones. Bingo, done. Okay, we can do the same thing with this one. But now we've got a flip. That's what the negative does. So that's our flip. Okay, and then since we're not in the parentheses, that's going to be our up-down action. So since it's positive, we're going to go up. So up 3. So we'll take all of our points. We do flips before we do shifts. So this is going to be a flip and then up 3. 1, 2, 3. This is going to flip, which means it stays in the same spot. 1, 2, 3. Flip, and then 1, 2, 3. Just like that. And then this one looks like this. And that's how we graph those ones. It doesn't matter if this was x to the 7th, x to the 9th, x to the 11th. As long as it was odd, we're still just going to use these 3 points and give it that general shape. Same thing with this one over here. X to the 4th, 6th, 8th. It's anyone that's to an even power. We'll use these 3 points and then shift them from there and give it that general shape. And we call it good. When there's a negative, it's a flip. So negative out front is a flip. Okay? So that's just transforming our most basic of functions. Okay? Now we can start getting into what we're going to be dealing with, like the meat and potatoes of the polynomials, which is the best part, exactly. It's going to be checking out, bless you, doggo, is going to be checking out, starting to figure out some features like zeros or end behavior or y-intercepts, x-intercepts, stuff like that. So with this part, it's just basically what we're doing in here is we're going to check for the end behavior. So it's how we're going to be going when we go to the far left and the far right. What's that going to look like? So first of all, we need to circle the dominating term. That's a really intense word there. Dominating term is the one with the biggest exponent. So like in this one, that's going to be negative 4 x to the 3rd. We're looking for the biggest exponent. So negative 2 x to the 6th. This one, it just so happens to be the first one. So that's 3x to the 4th. And then this last one here, it's going to be the first one again, 2x to the 5th. So we got to find that leading term. And then we want to find some things out about it. We want to figure out, is it positive or negative? So this one's negative. And then also, whether it's even or odd. This one's odd. Okay, so our arrows are going to be going in opposite directions. It's going to be going One's going to be going up, the other one's going down. Now, when it's negative, we're going to go down to the left and then up to the right. Wait, I did that wrong. Crap, I did that wrong. No! It's down to the right and up to the left. Oh, I hate odd. Okay, there we go. Yeah, that's right. Okay, now it looks good. And that's all we need. We just need the arrows. We're good. Okay. This one's also odd, but positive, so it's positive, and then to the fifth power is odd. So that means that now this is the one I meant right here. Up to the right, down to the left. Okay. For odd, if you're having a hard time remembering, like I just did a minute ago, actually more like 20 seconds ago, remembering which way is positive and which way is negative with odd. If you're going to the right for positive, you want to go up. So both positive directions. You're going to the left, which is the negative direction. You're going negative down. So you're going with like the ways that you would expect. When it's negative, you're going like opposite. As x is getting bigger, y is getting smaller. As x is getting smaller, y is getting bigger. So that's one way to remember. Even ones are a lot easier. This one's negative and even. Even they go the same direction, and negative does exactly what you expect. They go down. Okay? Positive and even, they go in the same direction, but now up, because that's the positive direction. So those ones are both going to go up. And that's all we need for this kind of stuff, for end behaviors, just the arrows. I know we did like that limit notation, all that stuff. Let's not worry about that just for this moment. All right, next chunk. I am going to need a pen this time. Next chunk. 7 and 8 are talking about using the remainder theorem or synthetic division to find f of c and then decide if c is a 0. So the whole point is we want to figure out, is c going to be a 0? Meaning like if this x plus 1 was like a factor of this polynomial. Or over here, this would be the factor x minus 2. Is that a factor of my polynomial? We're going to use synthetic division because that's the easiest way to do it. So synthetic division, we take our 0 we're testing, we're going to put that guy in the little multiplier box right there. Then we're going to write our coefficients for everything else in here. So it's 1, 2, 3, and 2. So it's all the coefficients. All right. Get the rest of my setup done. There's my remainder. It's going to go there. All right. First one just drops down. There's nothing crazy. Okay. From there, we multiply. So that is negative 1 times 1 is negative 1. So then we can add these two. 2 plus a negative 1 is 1. We've got 1 times a negative 1 would be negative 1 again. So then we'll get 2. And so then we get negative 1 times 2 would be negative 2. And then lastly, 2 plus a negative 2 is 0. If we get a remainder of 0, then yes, this is a 0. So yes. So x plus 1 is a factor for this polynomial. Okay? So that's what we're looking for. That's all it's asking for. It doesn't want what's the result or doesn't want to factor the rest of it or anything.
Wait, so what does it mean whenever it's 0?
What does this mean? Yeah. It means that that is a factor for this particular polynomial. That means that it is going to work. That is a 0, and that's all that that's asking for. Okay, so there's that one. Let's take a look at the next one. So with this one, the 0 we're testing is 2, so we'll put that guy up there. We'll put all of our coefficients, negative 2, 7, negative 4, negative 4, and then 0. So one thing we've got to make sure we do is that we have all of our coefficients represented, meaning all of the different exponents walking down from our biggest one all the way down to the constant term. So this is negative 2 for the x to the 4th, 7, negative 4, and then there's no constant term. Technically it's plus 0. So that's why we've got to have that extra 0 right there. Sometimes it works out that you don't need to worry about it, but we got to make sure we put it there just in case. Negative 2, that comes down. 2 times negative 2, negative 4. 7 plus negative 4 is 3. 2 times 3 is 6. Negative 4 plus 6 is 2. 2 times 2 is 4, so that's 0. Whoops. 2 times 0 is 0 still. It turns out it didn't actually matter having that 0 in the end or not. But, just in case, we're covering our butts. So we're good to go. Yes, that is also a factor because we got a remainder of 0. So that's what we care about in that type of question. Now when we get to number 9 though, number 9 is a little different. That one's not just looking to see are they zeros, it actually tells us that they are zeros. So for number 9, the following polynomial, 2 zeros are given. These are zeros. They should work. That's the point. It says find all the others and factor f of x into linear factors. So this one's a little different. Today when I was walking around, I was seeing people not finish this one all the way. They were doing the synthetic division, but then they weren't finding all the factors. Make sure you're looking at the directions and reading those to their entirety. So we'll pick one. I'll just start with 3 since it's the one on the left. And we'll go ahead and synthetically divide. So that's 4/3 squared x constant. Okay, cool. It's always good to check. All right, so that guy comes down. 3 times 8 is 24. Those two added together make 10. This would be 30. Negative 29 plus 30 would be 1. That brings me to 3. Negative 4 plus 3 is negative 1. 3 times negative 1, negative 3. That's a good thing. We want that. Okay? So where we're at now is we basically took this factor, so this 0, and we factored it out. So that's really x minus 3 would be the factor. And then now what we have left is x to the, since we started at the 4th, it's going to be to the 3rd, 8x to the 3rd, 10x squared, 1x, and then minus 1. We didn't really need to write the 1x, but that's okay. We could have just wrote x. So that's where we're at now. Now we know this 0 has to come out of here. Okay, we want to make sure we're using this one because we're trying to factor it in a way that's going to make life easier for us. So now we're going to take this guy and synthetically divide it by this 0. So negative 1. 8, 10, 1, negative 4, 1. Okay. We can do it with this one now. 8. So then that's negative 1 times 8 would be negative 8, which makes 2. Negative 1 times 2 would be negative 2. 1 plus negative 2 is negative 1. Oh, and then negative 1 times negative 1 makes positive 1, 0. Okay, that's what we wanted ultimately. So now what we have is that x minus 3 we started with over here. We've got x plus 1, which came from this one we just took out. And then what's left is now this polynomial right here. And since we started with x cubed for this one, this is going to be 8x squared plus 2x minus 1. Okay.
Wait, why?
You always walk down the degree by 1 after synthetically dividing. So we started with x to the 4th. So then after our next chunk, we ended up with x to the 3rd. Then after taking out our next factor, now we're at x squared. So we're just walking it down. I mean, we're just keeping it with. We're keeping it with. So like this original function we started with factored first to this guy. So where we took out the x minus 3. Now we took out this, out of this chunk, we took out the x plus 1. But then that x minus 3 is still there because we're still saying it's equal to what we started with. That's kind of the idea. Okay. From here we need to factor this. Okay. It's just a quadratic trinomial. Okay. I like doing a times c method. So a, b, and c. So then that's a times c would be negative 8. So factors of negative 8 that add up to b. That would be 4 and negative 2. I'm just going to go ahead and use the box since that one seems the most universally used. Negative 1 would go here. We'd have the 8x squared here. And then these would be my magic factors, which would go here and here.
How do you decide which one goes where?
Like between these two?
Yeah.
It doesn't matter. It would just change which one would end up here. They would just switch sides is all. But it's okay. Let's see. Between these two in the top row, they have a 4 and an x in common. So that would be 4x. These two have in common a 2 and an x. Okay, let's see. Between these two, that's negative 1 they have in common, and that's it. Then between these two, it's also a negative 1. So we have 4x minus 1, 2x minus 1. So this factors to, we'll have the x minus 3, we'll have the x plus 1 from before, and then we'll have a 2x minus 1, and then a 4x minus 1. So that's factored, but then we need to find the other zeros, which is setting each one of these equal to 0. So 2x minus 1 equals 0. 4x minus 1 equals 0. And then when we do that, we get x equals 1/2 and also 1/4. That's ultimately what the answer was supposed to be. Yes, that one's very involved. Sorry. It would be more like just the first step, really. But like, it wouldn't be to the 4th power, it'd probably be the 3rd power, and then it would be a quadratic. That'd be more likely. Like, instead of having to do it twice and then do it. Okay. Page 1 complete. You know the amazing part about this, Gabe? It's going to be uploaded to YouTube. Okay. Want this video to not to be too long. All right. Shut up, doggo. Minus 10 points off your test. Okay, you all heard it. It's on the YouTube now. Okay. What's up? Sure. You heard it here, guys. All right. So B, we're gonna ignore B. Okay, no thank you on that chunk. What we're going to do instead is we still need to be able to find all possible rational zeros. Just meaning, like, if you weren't given any zeros, like, how could you know what the possibilities are? So it comes by doing something called dividing p's by q's. We want to get p's divided by q's. So all possible zeros are going to be by dividing p's by q's. Now, p is all the factors of that last term. So that's why I say it's p. Because really it's all the factors of -3. So that would be all my possible p's are going to be plus or minus 1 and plus or minus 3. All right, those are all the things that multiply together to make 3. For q, that comes from the leading coefficient. And again, it's q because q is all of the factors of -2. So that's plus or minus 1 and plus or minus 2. Okay, since that's 2. Okay, so now that we know all of my p's and q's, then what we can do is take every p and divide it by every q. Luckily, we end up with 2 prime numbers, so this one actually is going to go pretty quick. So starting with 1, that would be plus or minus 1 divided by plus or minus 1, which would equal 1. So plus or minus 1. So that's our first possibility. Man, I did not set this up well. Let's just keep going the way I was doing it. We'll take 1 again and divide it by plus or minus 2 now. So plus or minus 1 divided by plus or minus 2 is going to be equal to plus or minus 1/2. There's another one. Now we'll take the 3's. 3 divided by plus or minus 1. So it's plus or minus 3 divided by plus or minus 1, which is plus or minus 3. And then lastly, we got 3 divided by 2. So it's plus or minus 3 divided by plus or minus 2. Which will be 3 over 2. Don't forget the plus or minus. Okay, so those are the 4, well, actually, technically it's 8 possible zeros. All right, that's the idea with those ones. You're just taking all the p's, dividing by all the q's. And these are just possible zeros. It doesn't mean there are zeros of that function. It's just that narrows it down from the infinite number of numbers we have in the universe to these 8. So I say we're doing a pretty good job.
So the q is always the first number?
Q is always the leading coefficient, so that first number. P is always that constant. Okay, always on the end. Okay? And then we won't worry about B and having to do that. All right. Now we can actually start making some of these sketches here. There we go. Okay. So, making these sketches, it's all about knowing a couple things. We need to know our end behavior, we need to know some zeros, and we need to think about multiplicity. So how they're gonna cross. What, are they gonna bounce? We're gonna cross, we're gonna squiggle, snake, whatever we were calling it, wiggle. So Easiest thing I can start with when these are already factored like this is that you can find the zeros. Like my zeros are going to be -1, 2, and 3. So setting each one of those equal to 0 would give me -1, 2, and 3. So those are my 3 places where we're going to run into the x-axis. Okay. The next thing we can do is think about their degree. So the degree of this function is going to be the biggest exponent we've got. Or you can look at the number of factors. So biggest exponent is 3. We've also have 1, 2, 3 factors. So our degree is equal to 3, which really what we care about is that it's odd. Okay, because that helps us with n behavior. So it's odd, and actually if we look at it, it's also positive, because that leading coefficient's positive. So our n behavior is going to look like this. It's going to be up to the right, down to the left. So positive, odd n behavior. So on the right, we're going to end up going up. On the left, we're going to end up going down. So that's kind of the idea there. Lastly, to know what happens in the middle, we need to know our multiplicity, which is just how many of each 0 there are. And it's this exponent here. So since our exponent on these ones, it doesn't write it, but that implies that it's 1. That means that they're all going to cross. So when a multiplicity is 1, they cross. So it's going to cross, do something, cross, do something in the middle, cross. Oops, there we go. That really should have connected that to what I had before. Oh well. Again, these are sketches, right? They're not going to be perfect. What's happening in between, like how high up we go or low, whatever, that doesn't matter. Just don't add anything. Like sometimes I see people, they're like, oh, it's going to do this and then do some funky thing here. No, you're adding zeros. Don't do that. Okay? That tells me you don't know what's going on. Only do what you know. So just make it basic. Don't go crazy. Don't do what I did here. Okay. Again, I like to start with the zeros, especially if it's factored for me already. So it's -3, 2, and 1. Okay, so -3, +2, and then +1. All right. Looking at, let's see, n behavior. Our degree is 4. Okay, degree is 4, which is even. That's really what I care about there. And it's positive again. So it's even positive, which means both up. So that means that that guy's going to go up and that guy's got to go up. So they're both going up. Now, multiplicity comes into play here. It's a 1 for the -3, so that's going to cross. It's a 1 for the -2, or sorry, for the +2, so that's going to cross. But our multiplicity of the +1, this guy right here, is 2. That's going to bounce. So instead of crossing at -1, it's going to just come up, touch it, come back, and there you go. So it touches and comes back. It bounces off instead of going through. Okay, so that's the difference between
Whenever it's,
that.
as an exponent, does it mean down, or?
If it's an even exponent, yes.
What's an odd exponent?
Odd exponent, it crosses still, but technically we say it like changes concave. It just squiggles. That's what we've been saying. Instead of going straight through, it like wiggles through. That's what happens on this one.
Okay.
So this one, there's only 1 0. It's just 1. That's it. There's only 1 0. This one was tripping people up today. 1 0. That's all there is. It's to the 3rd power. So that means that this is an odd degree, and that means the multiplicity means it's going to wiggle. Okay? It's odd, and then that negative out front means it's odd negative, which means that we're going to go up to the left and then down to the right. That's going to be our end behavior. So up to the left and then down to the right. That's it. I'm done. Odd, it crosses through, but it wiggles. So see how it wiggled instead of going straight through? That's literally it. You get to calculus, you'll start learning about changes in concavity and stuff like that. We're not worried about that just yet. Yeah. That's our sketches. Okay. On to the rational functions. These ones. Okay, so those rational functions. These are just, these first couple, it's just the transformation. So it's a lot like the other ones that we did when we started. It's just the basic transformation. So we start with knowing what the parent function is. The difference between them is the square. Right? If there's not a square, then it's just 1 over x is the parent function. If it's squared, then it's 1 over x squared, and that's the parent function. So when it's 1 over x, there's really only 2 points that really matter. It's just these two right here. Also, there are asymptotes that are on the axes. Okay, so these points are going to be here and here for these two. For this one right here, when it's squared, same 0.11, but then now it's -1, +1 instead. Same two asymptotes even too. So those would be the parent functions, and those would be the things that I want to shift. Okay, so let's talk about what we would have. With the x, means left, right, and it does the opposite sign, so that's -2, so our transformation is really going to be to the right too. Okay. The -1 on the outside here, that's our up-down action, and that's the same sign, so that's going to be down 1. So we're going to go to the right 1, and then down, or sorry, right 2, and then down 1. So that point right there ends up here. This point is going to go to the right 2, and then down 1, so it ends up right there. And then even the asymptotes move too, so this needs to go to the right too. 1, 2. There's my new asymptote. Okay. Down 1 for the other one, so this one goes down 1, so it ends up right here. All right, and then this is just we're just drawing those basic little L shapes. Okay, so just like that. Okay, vertical asymptote, x equals 2 because that's at 2. Horizontal asymptote, that's y equals -1 because we went down 1. And then our domain is basically just saying what those exclusions are. So x can equal 2, and then here y cannot equal, oops, that's supposed to be y. Y cannot equal -1. And that pretty much sums it up there. All right. Same kind of deal can happen with this one. Okay. We're just going to take these transformations. That's going to be opposite signs. So we're going to go left 1. Then we got the -3 out here. So we're going to go down 3. All right. So we'll take our points. We'll go left 1, down 3. Left 1, down 3. And then even those asymptotes move over too. So this goes left 1. So now he's there. Down 3. This one's going to go 1, 2, 3. And go right here. Now when it's the 1 over x squared, this one, the L shapes are kind of across from each other like this. It's really the only one where you end up next to each other and not like opposite of each other like that. Vertical asymptotes. X equals -1. Horizontal, y equals -3. Let's see, domain is what we're excluding, which is -1. Range is also what we're excluding, which is -3. Okay, so those are our basic parent function shifts from those two. Okay. Last complicated page here. It's our favorite ones. It's our favorite ones. It's all laid out for us. We've got our function. We've got our factoring, restrictions, reduced, vertical asymptotes, whole, horizontal asymptotes, and intercepts. And then we put it all together over here. Factoring. We see if there's something we can factor, which in this case, no, there's none. So no factoring needed here. Restrictions come from setting the denominator equal to 0. It's basically where are you going to divide by 0. So you just say, all right, take a factor, set it equal to 0. All right, so then x cannot equal +1. That's our restriction that we've got. And so that's actually, we can go ahead and put that in our domain too. X cannot equal +1. Okay. Reducing. That can only happen if we've got the same factor on the top and on the bottom. And then this one, that's not the case. So there is no reducing here. Or none. I don't know, grammar. Vertical asymptote, that's going to come from our restriction that's left here. So that's x equals 1 will be our vertical asymptote. And George, you are correct. Number 5 is also going to be a none because there was no reducing. Those two things go together. All right, if you end up reducing something, that turns into a hole. We didn't reduce anything, so there are no holes. Okay, so there are none. Horizontal asymptote. That comes from comparing the degree of the top with the degree of the bottom. Degree of the top is 1. Degree of the bottom is 1. So that means they're the same. This is our only weird one. This one's the weird one. When the degrees are the same, it's going to be y equals, and then what we'll do is we'll divide the leading coefficients. Not the degrees, the leading coefficients. So that's 3 divided by 1. 3 divided by 1, which is 3. So that's going to be our horizontal asymptote, is going to be y equals 3. Okay, so we've got our vertical and horizontal asymptotes. That also means that we know where our restriction is here. Y cannot equal 3. Alright. Now, intercepts, those will help us a lot. So we got x-intercept. We got y-intercept. X-intercept, we set the top equal to 0. So that's 3x plus 2 equals 0. That's going to be negative 2/3. So we've got x equals negative 2/3 right there. All right, so we know we got to be in this quadrant down here. Let's see. Y-intercept comes from setting x equal to 0. So what we'll do is we'll say y equals 3 times 0 plus 2. And then down here we'll have 0 plus 1. So that reduces to 2 over 1, which is 2. Or wait, was that a minus 1? That was a minus 1. Okay, sorry, I was about to freak out. Okay, yeah, that's minus 1 down there. So it's negative, negative. There we go. Okay. Whew. That was going to cause problems. Okay. Cool. Now we can graph it. We just need those L shapes. Where are they going to be? Which quadrant? So in this chunk right here, where we're to the left of our vertical asymptote, we already have 2 points below our horizontal asymptote, so we know this guy's got to be down here. Now, for over here, this chunk, whether or not we're up here or down here, my surefire 100% gonna get it right every time way is to pick a test point. So like, pick a test x, like say 4, plug it into the function and see what you get. Are you going to be above 3 or below 3? So let's do that. 4, let's actually scoot down. There we go. So if we do y equals, and then it's 3 times 4 plus 2. Okay, that's the top. And then we got 4 minus 1. So let's see what we get. Equals. Let's see, y equals, what is that? 3 times 4 is 12, plus 2 is 14, divided by 4 minus 1 is 3. 14 divided by 3 is about 4.6-ish. And that is bigger than 3, so that means we're going to be up here somewhere. So that means that we're up here. That would be our L shape. And again, it's just going to be a sketch. It's not like we're getting all fancy here. We're just saying, okay, this is what it looks like in general. And that's good enough. There we go. Got it. We're graphed. Okay. In general, also, it tends to be that on the vertical asymptote, they're going to kind of go in opposite directions of each other here. Okay. So that's the idea with that one. Okay, so we got that one. 17 we did in class, all together. The entire class. So, yeah, I was going to say, do you want to do it or you want to skip it? We literally did it in every class. I'm going to say we skip it. Yep, I'm going with it. I'm skipping it. Video's already super long anyways. I really don't want to.
It's already like 40 minutes.
It really is. Well, we paused a couple times, so it's probably seriously at like 30.
It's right there. It's almost 40.
No, I know. When it pauses, the timers keep going. But yeah. So yeah, let's get this over. I did that in the class. So.
You just need like x minus 4 on these.
So you just gotta be careful. It says vertical asymptote. So yeah, set the bottom equal to 0. So then minus 4. So yeah, it's gonna be x minus 4. So that one's gonna be b. Okay. What gets people is this. I was noticing this today. Horizontal asymptote. You're comparing degrees. So like degree of the top is 0, degree of the bottom is 1. When the degree is less on top than on bottom, it's y equals 0 every time. It doesn't matter what they are.
Wait, so how do you know if the degree is 0?
There's no x.
Oh, okay.
Yeah, when there's no x, the degree is 0.
How'd you get degree 1 in the bottom?
Because that's the exponent with the x. It doesn't say it, but that's the implied degree. So degree on bottom is 1. Yeah, this is going to be one of the longest review videos I've ever made. Okay. Exactly. Okay. I really hope I get the views on this one. Got to monetize, guys. For the function, it's the vertical asymptote again. So again, that's the one where you set the bottom equal to 0. So when you solve for that, we'd get positive 1. So that'd be that guy. 21, it's horizontal asymptote. So you're comparing the degrees. So it's degree of 1 on top, degree of 1 on bottom. So that means we're going to divide the coefficient. So careful, this is 1 divided by 1. So it just happens to be 1 again. We're not dividing the degrees. Don't get caught in that trap. It just so happens that they're both 1 on this one, so you're dividing 1 divided by 1.
So when it's always the same, you divide it?
Divide the leading coefficients when they're the same. When the degrees are the
So
same.
if it was x minus 2 over 2 minus 1, for example,
Yeah.
it would be 1 divided by 2.
Exactly, so it'd be 1/2. Yeah. You got it. Just careful with that one. That's going to get you. This one, again, it says vertical asymptote, so we're setting the bottom equal to 0. So that's x equals -1. So that's going to be b on that one. Hopefully the 23 isn't so bad. If the zeros of the polynomial are -3, 2, and -1, we need to find out which one we've got here. This one, it would be -1, 2, and 3. It's just opposite signs, so it can't be that one. D, is that what you said? That would be +1, -2, and then +3. So nope, not D. Remember, it changes signs because you're finding the 0. It's got to be B, okay? Because they all change signs. It's -1, 2, and -3. So that one's going to be B. All right. 24, that was our zeros one. This one was giving people problems too. So, this one, a removable discontinuity. I'll make sure I point this one out tomorrow when we're taking our test though. It's really, where's a hole? So we just got to find a hole. So it's just like when I went over 17 in class. We got to factor this thing and see where it's going to lose one, and then we got to find the right y coordinate too. So first of all, we got to factor the top, and we got to factor the bottom. Okay, luckily they're both 1 is our leading coefficient, so that makes life easy. We just need things that multiply to make -6, but then add to 5, so that would be +6 and -1. The bottom would be things that multiply to make -3 that add up to 2, so that's +3 and -1. So now, the whole comes from where they cancel, so the factor that cancels. Okay, so we will have a hole at the 0 from that factor, which will be x equals +1. So if I plug in +1, it'll divide by 0. So that's what we want. That's the x coordinate. So there is a removable discontinuity, so there is a hole. And its x is not 1, so we can at least get rid of those two. But then now we need to figure out, is y going to be -3 or is y going to be 7/4? So we'll take that and we'll actually plug in our x. We'll see what the y value is if we just plug that in. So that would be 1 + 6 over 1 + 3. Which is 7/4. So it's 1/7/4. Whoop, bloop. There we go. Bingo. Done. Cool. Have fun studying.
Don't forget to like, subscribe.
Don't forget to like, subscribe, and comment, and turn on post notifications. Follow. Yay. I love doing this with kids in here too. Good luck studying, guys.